I would like to introduce the new chair of the Lunar Exploration Analysis Group, Dr. Amy Fagan, who will introduce our new keynote speaker for the day.
Thank you, Sam. Well, I get the pleasure of welcoming NASA Administrator Jim Bridenstine, and to first thank him for taking time to speak to League today. We know he has a very busy schedule, and it means a lot to us to be able to talk to him. As the administrator, we all know he set us up on an inclusive path to the moon and worked hard to build bipartisan support in Congress for a return to the moon. He has a clear passion for space and federal service, beginning with his time as a naval aviator and a member of Congress. So thank you for your past and continued service. And with that, I'm going to let you have some time for your remarks, followed by questions from the League community. But I wanted to first remind people again, you're going to type your questions into the chat box. Sam and I will grab some of those questions and read them out to the administrator to respond to. So please be aware of that and start asking questions early and often. And with that, I'll turn it over to you, Jim.
Well, thank you, Amy. There we go. Thank you, Amy. Thank you. And Sam, I want to say your words are inspiring and true. And before I get into kind of the things I want to talk about today, I want to start by saying how happy I am to be back at League. I was fortunate to have the opportunity to speak to this group when I was a member of the House of Representatives. A good friend of mine, Bob Richards, we had been working on how do we provide authorization and continuing supervision within the Outer Space Treaty for these non-traditional space activities like going to the moon commercially. What is the path to do that? We really, we're working hard on using the payload review process for through the FAA to achieve that objective. And Bob asked me if I would speak at the League group, and certainly I was thrilled to be invited. In preparation for that, I read a couple of books. One, of course, was Why the Moon Matters by Paul Spudis. And we are extremely sad that he's not with us today. And another one was Moon Rush by Dennis Wingo. And what's fascinating is, as I was speaking to this audience, it dawned on me that the very people whose literature I had read to prepare for the meeting were sitting in the meeting. So if that's not daunting enough to speak to a bunch of planetary scientists and lunar scientists, and then have the people in the audience, that you're referencing as you're giving a speech. But I will tell you, it was an amazing discussion, very revealing and impressive. And now I have the high honor of leading this agency called NASA that now has an agenda to go back to the moon. And I like to say forward to the moon, because this time when we go, we're going to stay. And getting to the place where we have an Artemis base camp is critically important. And of course, speed is of the essence. And I'll tell you why speed matters. The challenge that we face going to the moon is not, it's not technological. The challenge that we face is political. And in order to achieve the objective, we need to go fast because it reduces political risk. The longer it goes, the more it costs, the more challenges we're going to have on the political front. At the same time, we have to make sure that in order to have a sustainable program, we have to make sure that wherever there is division, we eliminate it. I get asked over and over and over again as the NASA administrator, people say, tell us how you are going to prevent this program from getting canceled. You don't know how many times, and I know there's so much shell shock from going back to the Space Exploration Initiative of the 1990s, where we were going to the moon and then on to Mars and it gets canceled. And then the vision for space exploration with the Constellation program, where we're going to the moon and then on to Mars and it gets canceled. And what we have to do is we have to say, wherever there is division, we eliminate it. I heard Sam talk about bipartisan support. Amy, you mentioned it as well. That's exactly what we need. And in order to achieve that, we have to make sure that when we put together our thoughts and ideas, our programs, we're not artificially creating divisions. So, for example, when I was in the House of Representatives, it was shocking to me that Republicans were for the moon and Democrats were for Mars. And I was so stunned by this artificial division which made no sense. That I thought that was the first thing we need to do when I become NASA administrator. We need to let people know it's moon and Mars, not moon or Mars. There's divisions between people who want traditional aerospace contracting and people who want more commercial aerospace contracting. And guess what? If we go fast, it's not a question of which one you prefer. We're going to need all of it, and we're going to need all of it as soon as possible. So it brings people together. There has been this debate about whether it's human exploration or the Science Mission Directorate. And the moon was about human exploration, and the Science Mission Directorate was about robots and everything beyond the moon. And again, an artificial division. One of my first initiatives as a NASA administrator was the Commercial Lunar Payload Services Program, which of course is being run out of the Science Mission Directorate, because the moon is in fact about science. And of course, you guys saw just recently, part of the Artemis program, we asked for white papers. We want to know, how should we do science on the moon on Artemis 3, the first mission since 1972? How do we do science on the moon? And of course, we got great white papers back, and those are being evaluated now. But that's being evaluated by the Science Mission Directorate, working hand in glove with the Human Exploration and Operations Mission Directorate. Again, the false narrative that there was this narrative in the House when I was there where Republicans were for human exploration and Democrats were for science. Again, eliminate those divisions. If we're going to go to the moon and we're going to go sustainably and we're going to go onto Mars, this is one team, one objective. We need to be united in this effort. So we initiated the CLIPS program. The CLIPS program, of course, is under the Science Mission Directorate. We have the Science Mission Directorate informing us how we're going to do science on the surface of the moon. And all those ideas are, of course, going to be vetted right here by League, so that ultimately we can make good decisions going forward. So we can maximize the amount of science we can get on that first mission where we're going expeditiously. So I guess the narrative here is, and I'm going to keep saying it, wherever there's division, we need to eliminate it. And this is about getting to the moon with a purpose. We want to be able to sustain on the moon, but we also want to be able to get to Mars. They are not exclusive. They, in fact, work together hand in hand. So I think we're in a really amazing time as a nation. I will tell you right now, for the first time since 1972, we have a human landing system not only funded, but we have 3 landers that are now under contract for an eventual development. And that's a great place to be. The House and the Senate have passed bipartisan legislation to fund that human landing system. The CLIPS program, of course, is funded. And that has not happened since 1972. The House of Representatives has passed an appropriation for the Commerce, Justice, Science Appropriations Subcommittee. And it went through the full through the full Appropriations Committee and then to the floor of the House, and it passed. And in that bill, there was, and that's a bill that was run on the Democratic side, and they had $600 million for the human landing system in their bill. Here's the point: it doesn't matter if you're a Republican or a Democrat. Right now, there is bipartisan consensus that we need to go to the moon, that we need to use the moon for science, that we need to use the moon for exploration, that we need to use the moon to get to Mars, and that the moon is tremendously valuable. And I want to tell you that is a great position for us to be in, and we have to sustain it. We have to sustain it not just for Artemis 3 2024, but we need to sustain it for decades to come. So when we think about the moon, we think about all of NASA as a whole. We think about within the Science Mission Directorate, heliophysics. The moon is an amazing study of our sun. We think about how the regolith is a repository of data and information from the early solar system and the early sun, because it doesn't have an active atmosphere, it doesn't have an active hydrosphere, it doesn't have an active geology. Those subatomic charged particles coming from the sun are today on the moon, right where they were billions of years ago. Although here we had to go and make a discovery that the moon is rusting. So maybe we're not as sure as we used to be about the value of the moon from a heliophysics perspective. But I'll tell you, there's going to be a lot more data about the early sun at the moon than we'll ever be able to discover here on Earth because of our magnetosphere and our geology and our hydrosphere. So the moon is, in fact, in my view, a very good place to go and learn as much as we can about our sun. And of course, now we're learning, and I don't know if this is, obviously it's not proven or anything at this point, but it's actually the Earth's oxygen that is causing the iron oxides on the moon to potentially rust. Although we've got now understanding that there's rust in areas, maybe on the far side, where there's a real question as to how oxygen could have gotten to the far side of the moon. But here's the thing: there's so much more to learn, and the moon is a tremendous place to go and get the science and get the information that we need. So heliophysics. We think about Earth science. You know, maybe there's disagreement about how the Earth and the moon formed, whether it was one body, maybe it formed separately. Bottom line is we're in the same plane going around the sun, and we're made of very similar components. And so when we think about the moon and the Earth, we can actually learn a lot about the Earth by going to the moon and learning, what is there at the moon, and maybe what was the Earth like, billions of years ago. We think about, so it's about Earth science, it's about heliophysics, it's about planetary science, because when we go to the moon, it's going to be a launching point that's going to open up. Sam talked about this. It opens the door to the entire rest of the solar system from the moon with human spaceflight. Make no mistake, we'll have to have some technological advancements with things like nuclear thermal propulsion, nuclear electric propulsion, those kind of things. So it's about Earth science, planetary science, and physics, heliophysics, not just heliophysics, but astrophysics. So one of the missions that just has me really excited is DAPPER, which is, of course, an instrument that is going to be in orbit around the moon that is going to be looking out into deep space, but from the far side of the moon, where it's extremely quiet from an electromagnetic spectrum perspective. We're going to not only be able to assess, the solar or the universe after the Big Bang, after I should say cosmic dawn, but we're going to be able to see the dark ages after the Big Bang and before cosmic dawn. And we're going to be able to do that with the DAPPER mission, which of course is being led out of the Ames Research Center out in California. But here's the thing about the DAPPER mission that is so important. It's normally a $500 million mission, which would be cost prohibitive for, when you try to balance, all of the things that we have to do within astrophysics. It would be cost prohibitive, except for the fact that we're going to have humans living and working on the moon. We're going to have the gateway around the moon. We're going to have a communication architecture around the moon. So all of a sudden, instead of a $500 million mission, it now becomes a $90 million mission. And the value of that is here you have human exploration and the Science Mission Directorate directly benefiting from each other. Again, unifying the agency, unifying the different parts of NASA. And I know Lori Glaze is coming up. She's our planetary scientist, and she's been doing great work having people understand that the moon is about planetary science. But it's not just planetary, it's astrophysics, it's everything else. So this idea that there's these divisions, we're eliminating it. We're going forward in a unified fashion. The astrophysics piece of course, I think is the most fascinating. The idea that we could use a very low frequency antenna on the far side of the moon, basically a wire antenna, to also get astrophysics data that historically has not been available because of the value of the far side of the moon. All of these things are exciting. But of course, even more so is in situ resource utilization, the discovery of maybe precious materials, precious metals, the utilization of the water ice. So here's the thing. The moon is the place where it all comes together. Everything comes together at the moon. It unifies us as a nation. It unifies us, in fact, as a globe. We did an event the other day. We invited, this was before the pandemic, so I say the other day, but it would have been, I don't know, I guess around the first of the year, we did an event where we invited all the nations of the world to have a meeting about how they'd want to participate in the Artemis program. We had 26 nations come to that. Many of them didn't even have a space program. Australia established a space program, and they're dedicating its entire budget to the Artemis program. So this is a very exciting time. It's unifying. It's hopeful. We look at what's happening in the world today, and people are stressed and concerned about the future. But this is something I think that gives us a bright, shiny hope. And I'll tell you, we saw that, of course, with the launch of Demo 2, which was the SpaceX Crew Dragon going to the International Space Station. The entire world tuned into that one launch. Imagine what they're going to do when we go back to the moon, and this time when we go sustainably. So I think I'm thrilled to be here at League. I'm thrilled for the advocacy that the folks here are involved in, and I'm thrilled of the science that you guys are involved in. And I'm happy to answer questions with whatever time I may have remaining, Amy.
Great, thank you. We actually have about 16 minutes for questions. So I'll get you started off with, I'm going to use my chair prerogative here, and I'm going to ask you the first question. How do you see the commercial lunar sample acquisition evolving? Can you talk a little bit about that announcement from Thursday in case people hadn't heard? And then how do you see it adapting and evolving and continuing on and growing?
Yeah, so this really goes back to back in 2015, I was in the House of Representatives. We were getting ready to pass the American Space Launch Competitiveness Act in the House of Representatives. And this was a bill that dealt with specifically launch, indemnification kind of clauses, regulatory kind of burdens and how to relieve launch companies from the regulatory burdens. But it also had Bill Posey had a separate bill about lunar resources. And we made an effort to amend the Commercial Space Launch Competitiveness Act to basically define the American position for the Outer Space Treaty. And the Outer Space Treaty says that you cannot appropriate the moon for national sovereignty, which we all agree with and support. But the question is, what if there are tremendously valuable resources there, and now because you can't appropriate for the moon for national sovereignty, does that mean you can't have access to those resources? And I think maybe somebody might have an open mic here, but I think the point is, if we look at international law and the precedent that has been set already over the oceans, for example. You think about tuna or you think about energy. It can be extracted from the oceans, and guess what? If you apply your resources and your sweat and your equity and your investment to extracting tuna, you get to own the tuna that you extract from the ocean, even though you don't own the ocean. And that's true with energy as well. And I think that those rules, as a Navy pilot, I used to fly over international waters all the time, and we would get queried by other countries about, what airspace we're in and that kind of thing. But we would always respond with, I'm a sovereign U.S. naval aircraft operating due regard, those key words, due regard over international waters. That is not by accident in the ICAO standards for flight in international airspace. Due regard means basically, I won't interfere with you and you won't interfere with me. And as long as we hold that to be the case, everybody's going to be just fine. That's the kind of activity we need on the moon. And that's one of the reasons the Artemis Accords are important. It's one of the reasons I think it's important that we actually make an effort to extract a lunar resource and then trade it. It's not enough if NASA just brings home some more lunar regolith. We need to have the ability to have commercial companies go to the moon, extract some regolith, and then have that as a property right. You don't own the moon. It is not owned for national sovereignty, but if you extract a resource, you can have the rights to that resource, and it can be traded. And I think it needs to be traded among private individuals. It needs to be traded among public companies, and it needs to be traded across borders. And if we can establish a binding international norm that is similar to what we see in international waters, I think that sets a precedent where there's going to be an effort to capitalize and actually go to the moon. So I think that this effort that we put forward is important. We're not, we're not suggesting that with this first purchase of a lunar sample, this isn't about making a huge discovery, although you never know, one could be made. This is about proving a concept that if you extract a resource, you can own it, NASA can buy it. And if you extract other resources, other people can buy them as well. And I think if we do that, I think it's going to set us up for expansion and growth and development and industrialization. And ultimately, these are the things that we're going to need if we're going to be, if humanity is going to be living off the Earth for long periods of time.
Great, thank you. Sam, did you want to take the next question, or do you want me to jump right into the next one that I have written down from one of our participants?
No, I think you asked a very good question. Let's jump into the Q&A here and let the community ask some questions.
Okay, so we've got a question from James Rice, who's wanting to know about the astronaut activities that are going to be going for Artemis, and have astronauts been selected for those missions? If so, how many? Has training started? And when will those crews be announced?
Yeah, so that's another important question. So, and by the way, I'm very excited about it because I think that once we announce an Artemis kind of cadre of astronauts, there's going to be lots of media, and people are. It's going to inspire young people to maybe one day see themselves going to the moon, and so I think that that's going to be a great day. It will, I think, be reminiscent of, the Mercury 7, if you will. Which of course inspired a lot of people across this country, many of which are even today working at NASA. So not that the NASA workforce is that old, but there are some people that have been providing great capability to the agency that were inspired by those first flights. So we have not announced what our Artemis cadre of astronauts, who those people are. We have not selected any astronauts at this point for any specific flights. Usually those decisions are made about 2 years before a flight. I think, we want to do that. We want to do it sooner rather than later. But we're not there just yet.
Okay, so there's a second question that we have from Neil Wolf related to astronauts and boots on the ground. Is there any sort of plan in the future for returning to the Apollo sites and, say, getting some of the material from the lunar roving vehicle or the batteries and seeing how these materials have fared in space for 50 years?
So those decisions have not yet been made. For the first mission, Artemis 3, our objective is to get to the South Pole. And of course, the South Pole is where there's the most interest right now, because that's where the water ice is, and we need to characterize it, and we need to understand how to extract it and utilize it. But I would imagine that there is going to be great interest in some of those sites, and it would not surprise me if, for example, if we made a determination that the South Pole might be out of reach for Artemis 3, which I'm not saying it is or isn't. The question is, okay, if you're going to go to the equatorial region again, how are you going to learn the most? And you could argue that you'll learn the most by going to the places where we put gear in the past. So there could be, scientific discoveries there, and of course, just the inspiration of going back to an original Apollo site would be pretty amazing as well. So, and establishing, again, norms of behavior. We want to make sure that those sites are protected forever. So I think there's opportunity there as well. But those decisions haven't been made at this time.
So we've got 8 minutes left, just to let you know.
I'll be quicker.
Okay. We have a question from Clive Neal that I think he's been asking a lot of people. of what is your definition of sustainable or a sustained human presence on the moon. What does that mean?
Right. So there's a couple of things that go into that. Number one, we need to have access to any part of the moon anytime we want. And so it doesn't mean that we're going to have a 1.0 human presence on the surface of the moon by 2028, but we need to have access to any part of the moon anytime we want through the Artemis program. And if we can get to a sustainable presence where we actually have access to the surface of the moon by 2028, we should, of course, shoot for that. And the way it ultimately becomes sustainable is when our commercial providers end up providing capability that we ourselves at NASA are not necessarily paying for. And we're seeing that right now with commercial resupply and commercial crew to the International Space Station. So our commercial resupply partners, SpaceX and Northrop Grumman, and our commercial crew partners, Boeing and SpaceX, their goal, and in fact on resupply and on crew to a good bit as well, their goal is to get customers that are not NASA. And the reason they do that is because, volume drives down costs. It drives down costs for the user, and it creates a competitive market. So NASA needs to be a customer, one of many customers, but we also have to have numerous providers that are competing against each other on cost, innovation, and safety. These are all things I'm sure this audience has heard me say millions of times. But that same principle applies to the moon. So if we're going to have sustainability on the moon, we need to have NASA be a customer eventually, and we need to have suppliers that are competing against each other on cost and innovation. So the question is, what are the discoveries that are going to be made on the moon that entice private individuals, corporations, to capitalize and spend resources to go to the moon? And I know this group, League, knows what those opportunities are or are not better than anybody. But there's going to be a value for the U.S. government here that is going to be scientific in nature. There's, I think, going to be a value by U.S. industry that could be tourism or resources in nature. And if we can develop that together, I think we will attain a sustainable presence on the moon.
All right, you got 5 minutes left. So
Okay.
I'm going to go ahead and apologize to everyone who's asked really wonderful questions that we just can't fit them all. But there's one question that I'm sure everybody kind of has in the back of their minds, and it's an election year. So it's a question from Ryan Watkins of, really how to ensure that Artemis continues despite any change that we have on the horizon. I mean, there's political changes that could potentially be happening, but we've also learned that a lot of changes have happened this year due to a global health crisis. So what sort of plans are in place to ensure Artemis's continuity no matter the hurdle?
Yeah, so I think we're in good shape, and I'm going to be honest. Right now we have bipartisan support in the House, bipartisan support in the Senate. People are ready to go back to the moon. There's a big demand after the 50th anniversary of Apollo 11. The American public are aware of Artemis, which is important. They want to see. Look, I'm the first NASA administrator in history that wasn't alive when we landed on the moon, and that is a failure of the nation, and everybody knows that. So the time is now to put aside differences and just go get it done, and this time do it differently than we did before. I will tell you, I'll give you an example. I think this is just an amazing thing. So it was not August, but the previous August, I went out to Mountain View, California, visited the Ames Research Center, and I did it with a purpose. Nancy Pelosi, the Speaker of the House, was going to have Women's Equality Day, and she was going to do a big event and invite a number of women to talk about women issues. And I asked her if she would do it at the Ames Research Center, and we could talk about Artemis and the value of going to the moon under the name of Apollo's twin sister, so that this time when we go to the moon, we go with all of America. And we have this very diverse, highly qualified astronaut corps that includes women and represents all of America. And Nancy Pelosi absolutely agreed to it. She said she was very supportive of the program. And when it was over, she and we flew a simulator together. We landed on the moon 3 times. I nailed it every time. I was right on the spot every time. But I'll tell you, when it was over, she tweeted it out, and then the vice president retweeted her tweet. That is the power of the moon. That is the power of space exploration and discovery. It unites people. That, you know, we can put aside our differences and say, look, this is bigger than any one of us individually. We need to make sure that we do this for the good of the nation. And we've been doing that across the nation. I've been doing town halls with members of Congress on both sides of the aisle. Again, our budget request right now before Congress is $25.2 billion. When I became the NASA administrator, our budget was $19 billion. We're now $25.2 billion. We're talking about a 25% increase in a matter of just a couple of years. That doesn't happen unless every day we, and I say all of us, are working in an apolitical, bipartisan way to achieve the outcomes that we all seek, which is the sustainable return to the moon. But it goes back to unity. Anywhere there's division, we need to eliminate it, and we need to prevent any kind of artificial divisions from being put into place for political reasons or partisan reasons. And we need to be focused like a laser on the objective, which is getting to the moon. And I think we can do it. I'm very confident it can be done.
That's really nice to hear. Sometimes it's nice to get that confidence coming out that, yeah, that we're going to the moon and we're going to stay, and that this is a really exciting time for us. So thank you for your words. I'm gonna stop there because I know that we'll end up going over if we keep asking you questions. We can fill up the entire day. Right. On behalf of everybody here, because we can't all stand up and clap, thank you very much for joining us. And we really,
Amy, thank you.
So virtual claps.
All right. I appreciate you guys very much. Thank you for having me. We'll do it again.
Thank you.